Hello friends, welcome back to another video. This one, I was hoping to do something kind of quick. Let's find the derivative of the inverse function. So knowing that d by dx of f of x is f prime of x. I mean, this is just notation, but let's say that it's easy to find the derivative of f. Then can we find an expression for inverse, f inverse of x, such that it depends on f prime and f inverse? So in other words, know f prime, f, and f inverse, and want f inverse prime as a function of these three or two. So let's see what that would be. First of all, well, we know that f inverse of f of x is equal to x. So let's differentiate both sides. So d by dx of f inverse of f of x is equal to d by dx of x, which is just 1, right? Okay. And of course, on the left-hand side, we can just apply, d by dx to a composition of functions. So I can rewrite this as f inverse composed with f of x. So what I will have is d by dx. Well, let me write it like this. I will have f inverse prime of f of x. Let me just write my 1 like this so it looks different from prime. So f inverse prime of f of x times f prime of x. Okay, that's equal to 1. Okay, so now we can divide by f prime of x, assuming that it's not equal to 0. So assume f prime of x not equal to 0. If that's true, then f inverse prime of x is equal to, let's see, we'll have, oh, sorry, not of x, of f of x, 1 over f prime of x. Okay, simple stuff. And now, I'd just like to get rid of f of x in the left-hand argument. So set x equal to f inverse of y. Then we have f inverse prime of y equals 1 over f prime of f inverse of y. Okay, and that's it. So f inverse prime is just f prime composed with f inverse. We could even write it without the arguments. So f inverse prime is equal to 1 over f prime composed with f inverse. Very nice. Pretty simple stuff. There we go. Short video for today. Maybe actually, let me just show some application to this. So let's say f of x is equal to e to the x. So f prime of x is e to the x. No biggie there. And what did we just derive? We derived that f inverse of x, f inverse prime of x, is equal to 1 over f prime of f inverse of x. Was it like that? Yep. Okay, so this means that ln prime x, which we know is 1 over x, is equal to 1 over f prime is just e to the x, so e e to the f inverse of x, it's ln x, which is just 1 over x. Very nice, very cool. So it works. Of course, ln x, it's easy to differentiate, but we could use some more complicated functions, and yeah, it would be nice to know this. Like, for example, I don't know, I mean, for me, think of f of x equals tangent inverse of x, or even tangent hyperbolic inverse of x. You know, I don't know these by heart. It would be pretty cool to use the inverse formula for that. Okay, maybe I'll do that in another video. See you, bye-bye.